All right, another very common type of problem is half-life. So if half-life, we talk about how much time it takes for half of the substance to be there. So then our rate of change is a half generally. So looking at this problem, I've got iodine 131. So 131 is just the type of iodine. It's not numbers that are going to be in our equation. So we use it to test for thyroid deficiency. A healthy gland absorbs it all, and the half-life is supposed to be 8.2 days. So notice that if my t here is measuring in days, we're dividing by 8.2 to show that every 8.2 days is when the half-life happens. So my decay is modeled by this equation. Here's my amount left. Here's my starting amount. So after how long should they have 25% of it left in their body? So my amount left is going to be 25% of the original amount. And I want to know my time, so t is what I don't know. So 25% of the initial amount, that's the same as saying 0.25 of the initial amount. So that's how much my amount left is. So now I'm going to come to my equation, plug in what I know. I want 0.25 of the initial amount. I don't know what the initial amount was, but that doesn't matter. Times 1/2 of t divided by 8.2. When I divide by both sides by my initial amount, it cancels out. That's why it doesn't matter how much I had initially. So now I've got 0.25, that's the same as 1/4 equals 1/2 t divided by 8.2. Well, this one I can solve algebraically. I can keep going because I know, of course, 1/4 is the same as 1/2 squared equals 1/2 t over 8.2. If I didn't know that, I could use logs to solve, but now I can say t divided by 8.2 has to equal 2, setting my exponents equal. So the time it takes is going to be 16.4 days. Again, if I couldn't do this exactly, then I would move to logs, and I would use my logs to solve it.